What's that? Did someone say something? Oh, division, and also what's the partner to division? Multiplication. Okay. So when we say that the ratio is what we're looking at, we're talking about multiplying. It's really multiplying that I would focus on, but sometimes you might see it as a dividing by the same number every time. So instead of adding and subtracting the same thing, which ended up looking like a line, we're going to be multiplying or dividing by the same thing every time. So these graphs wouldn't turn out to like be in a line. You can see it as division, but just so you're aware, if you're saying like, oh, you divide by 2 every time to get to the next term, you're really multiplying by a half. So I would focus on like multiplying by the reciprocal of what your division is. Okay. We're going to call the common ratio R, so that's similar to like how we called the common difference D. So there might be examples on the quiz where you have to like name a common difference or ratio. And then here's an example of a geometric sequence, 1, 2, 4, 8. You can tell it's geometric because why? You're multiplying by 2 every time. So you do a times 2, times 2, times 2. So would you agree that R is 2? Can you kind of work with your pods just really quickly and see if any pods can come up with like a potential formula rule for 1, 2, 4, 8, something that might work for this geometric sequence if we're multiplying by 2 every time? See what you can come up with. You might not get the answer in the end, but let's just throw out some ideas. Okay, so we're looking for a rule. Anybody got anything that they think is on the right track or actually works? Caitlin?
2 to the n minus 1 as an exponent.
2 to the n minus 1, like all of that up in the exponent? Like this?
Yeah.
Okay, so let's think about that. If we were doing the first term, a sub 1, that would be 2 to the 1 minus 1, which is 0, which is 1. That works. If we try the next one, a sub 2, we'll get 2 to the 2 minus 1, which is 1, which is 2. That works. All right, and then we'll have 2 squared and 2 cubed. So it seems to be working okay. Can you give us like a little bit of insight to how you... Was there anything going through your brain that you could share with us?
No, I just remembered what we did yesterday.
Oh. What did we do yesterday?
I don't remember.
You did remember, but now you forgot. Alex?
It's similar with the like slope formula with the 10 plus whatever it is pushed up to the next one.
Oh. Okay. Yes. Why exponential? You say it's pushed up to the exponent. We haven't done our exponential chapter. That's actually our next chapter, which we were going backwards to section or chapter 6. But I think you study exponentials at the very end of Algebra 1. Why is it going to be exponential, Morgan?
Because that's how many times you're multiplying R, which is what, like how many times you're doing the
Do you remember our discussion I tried to make pretty clear yesterday? Like, if you notice that your pattern is like +4, +4, +4, +4, we feel like we should write n plus 4 in our rule, right? But that actually doesn't work, because then you're only adding 4 one time. Okay? If you're doing +4, +4, +4, +4, that actually turns into what operation? Multiplication, 4 times n, right? So repeated addition is multiplication. Okay? And now today, if you're doing times 2, times 2, times 2, times 2, you don't just want to have like a times 2 in your formula. Then you're only multiplying by 2 once.
It almost works.
You want to multiply by 2 a lot of times. And so repeated multiplication turns into a power, right? Like x squared is x times x, but x to the 5th is x times x times x times x times x. So yeah, this is our repeated multiplication. Now you got to do a little bit of tweaking there, because if you left it as 2 to the n, it was too big. Okay. So if you maybe started with an exponential 2 to the n, then you would check your first term and you're at 2 to the first or 2, and then your second term is 2 squared, which is 4, and your third term is 2 to the third, which is 8. And you might recognize like you're always one term ahead. So then just subtract 1 in the exponent. You'll be one term before. All right, anybody got any questions on that one? Here's the actual formula for the explicit rule of a geometric sequence. If you are digging the formulas that you get, write this down. Make sure you would know it. If you're going to rely on a formula, then you got to know it inside and out if you're not going to go based off of patterns. Okay. So it says a sub n equals a sub 1, which is going to be your first term, times your r, which is your common ratio, and then to the n minus 1. Now, I'm going to flip back really quickly to Caitlin's rule, because I think hers doesn't look like it has all this stuff, right? Hers was just 2 to the n minus 1, and 2 was our r value, our common ratio. What's the first term of this sequence? 1. Does she really have a sub 1 times r to the n minus 1? Yeah, technically there's a 1 out front right here. Does she have to write that 1 times 2 to the n minus 1? No, because we know the identity rule, and we don't necessarily have to write it. But that would be using the geometric formula. You would put your first term in for a sub 1, you would put your r in for, your 2 in for r, and then you would have raised to the n minus 1. Okay. Now, I also want to talk today about this whole n minus 1 business, because I also gave you yesterday, right? I gave you this formula that the book uses, a sub 1 plus n minus 1 times d. Okay. So what's nice about the connection between these two formulas, if you're a formula-driven person, I said, I don't really use that one. I like to use the linear function. It makes so much sense. What's nice about these two formulas is kind of what Alex was getting at, that it kind of looked like the slope one, but the other stuff was moved up in the exponent. Okay, here's the reason. If, say, I wanted to do a sub 1 in this arithmetic rule, then the rule would be a sub 1 plus something. And the only way a sub 1 will equal a sub 1 is if I add what? 0 right there. Okay, so I don't actually want to add any of my common difference on the very first term. The first term is the first term. The common difference is already in there. So the n minus 1 is there to say, like for the second term of the sequence, you've only added the difference once. For the third term in the sequence, you have added the common difference 2 times. And it's kind of like the question that Carly asked with the 11, 7, and 11. We added the common difference 4 times. Okay. When there's really like 5 terms up there. So that's our n minus 1. That's going to be 0 times d. So this is the same thing happening up here. The only way that this is ever going to equal a sub 1, have a sub 1, is if I multiply by r to the 0. Because then r to the 0 is just 1, and 1 times a sub 1 is a sub 1. So then they'll be equal. Okay, so that's the only way that works. Thank you. So that's kind of like a little bit of insight into why you see that n minus 1. Okay, can you tell me if these are geometric? And whether or not they're geometric, you might stop and think about patterns and could you write a rule? So if you want to share out with your pods, go ahead and do that right now. Are they geometric? Whether or not they are, can you write a quick rule for us?
Actually, no, it's not my shoes.
It's my ankle.
They're white shoes. Yeah. What you did? White shoes. So many girls wear hoops. Everybody wears these too. It's like until everybody else wears them. And then the R is that one is not used to it. And it just
Second one's not.
you see it one time.
Well, those are multiples of 3. Like
White
Yeah,
confidence.
but it's positive.
I still have
Okay, I'm going to interrupt. Is the first sequence geometric? Yes? What is your R? 4. So 4 times 4 is negative 8? No? So is there a different R? Is it geometric? No. What would you have to multiply 4 by to get it, negative 8? Negative 2 is negative 8 times negative 2, 12? No. So there is no common R value. So the answer to this one for geometric will be a no. In fact, this problem looks a lot like our warm-up problem. Okay, so now I've just said like a geometric sequence is when you multiply or divide by the same thing every time. Remember in the warm-up, Carly told us we had warm-up multiples of 3. These are all multiples of 4. If you have multiples of a number, like multiples of 4, are you multiplying by the same thing every time? No, you're adding the same thing every time because repeated addition is multiplication. That's why they're called multiples. So if you wanted to write a rule for this one, then you would use the multiples of 4 for n. And then like we did in the warm-up, we would choose to raise negative 1 to some power. Would we use n or n plus 1? Would be the n plus 1 because we need it to be positive, negative, positive, negative. Okay, is the second one geometric? Yes. What is the ratio? 3. So 3 times 3 is 9. 9 times 3 is 27. Common ratio? No. Are either of them geometric? No. Fooled you. It's easy to jump to that. You see, like, I heard some groups say, like, multiples of 3. So it's easy to be like, oh, yeah, you're multiplying by 3 because 3, 9, 27. But you have to watch your signs on that one. Okay, this one would be a little bit more complex for us to write a rule. I think we didn't see one that was positive, positive, negative, negative. But there's really no way to, like, work with our negative 1 to the powers to make it be positive, positive, negative, negative. So what could potentially happen if you were trying to write a rule for a sequence like this is maybe you could try to write rules for like odd numbered terms, so like the first, third, fifth, seventh term of the sequence, and then try to write a rule for even numbered terms, the second, fourth, sixth, eighth term in the sequence, because then you might actually have that alternating sign piece. Okay, but I won't worry about that. Writing that rule would be a little more complex. I wouldn't put that on a quiz or a test. Okay, let's do this example. Write a rule for the sequence. Okay. If you're seeing this on your quiz on Friday, you might check. Am I like subtracting the same thing every time? No. Am I multiplying or dividing by the same thing every time? What would you have to multiply 5 by to get 2? 0.4, or we could just think about it as 2/5, right? If you multiply 5 by 2/5, then the 5s will cancel out and you'll get 2 left over. 2 times 2/5 is 4/5, which is 0.8. Okay, 0.8 or 4/5 times 2/5 will get us to 0.32. If you're having a hard time finding your common ratio, what I would suggest you do is take like the second term divided by the first term. So like work backwards. That's an easier way to find your ratio. So 2/5. And then like maybe in your calculator check, is that the same thing as a sub 3 divided by a sub 2? Yes, it is. Is that the same thing as a sub 4 divided by a sub 3? Yes, it is. So as long as you're checking those ratios from consecutive terms, that they're all 2/5, which, like Austin said, if you're doing it in your calculator, it would be 0.4. Okay, so the rule for the sequence is a sub n equals. Let's use a sub 1 times r to the n minus 1. What's your a sub 1? 5. What's your r? 2/5 to the n minus 1. You're done. It almost feels too easy, doesn't it, the geometric one? If you know how the geometric sequence works, you just got to plug in first term ratio. Raised to n minus 1. Okay. One thing to be careful of here, sometimes people kind of jump the gun and they'll be like, oh, hey, let me multiply these two numbers together, a sub 1 and r. Can't do it. R always has an exponent on it. And in order of operations, you have to do exponents first. So you wouldn't be able to multiply them ever. Okay, to find a sub 8, of course, you would just make the substitution, right? Can you type it in your calculators and make sure you know where your exponent button is? That would be 8 minus 1, or I usually just type in 1 less than the term that I'm trying to find, so raise it to the 7. I'm getting 0.008192. It is a terminating decimal. It only has 6 numbers after the decimal. So I usually don't tend to, because I'm talking about a sequence, I'd actually want the exact term. I usually try not to round those. With geometric sequences, because you're multiplying or dividing by the same thing every time, you're very likely going to get some really small answers or some really big answers. There may even be times when you get like scientific notations. Because if I multiply by 5 20 times, I mean 5 to the 20th is huge. So you might get a scientific notation in your calculator, but just you can round that one and write it out in scientific notation. Okay, one last slide, then you'll be free. We're going to write the rule for geometric sequence. Suppose I give you an example where I tell you the first term in the ratio. Easy to write the rule? Yeah. A sub 1 is 4, R is 10, so A sub n equals 4 times 10 to the n minus 1. Okay, remember, you want your first term times your ratio, but you got to raise the ratio to the n minus 1 so that when you're finding the first term, you don't actually multiply by the ratio. Otherwise, it won't be the first term. Okay, this second one is the other one that we asked about on the homework for today where you're given two different terms. So we're going to kind of like think similarly. Okay. So do you agree that like in this sequence you have like the 15th term, which is 12, right? And then there'd be the 16th, 17th, and 18th term, which is negative 96. And in a geometric sequence, because I know it's geometric, how am I getting to the next term? Not specifically, just generally, in a geometric sequence. I'm multiplying by some common ratio. So don't I take 12 times r, and I get my 16th term? And then I take that times r, and I get my 17th term? And then I take that times r, and I get my 18th term? So I could write an equation that says 12 times r cubed is equal to negative 96. It's kind of what I presented to you in the homework review that we went over. Are you okay with this? 12r cubed equals negative 96, how I thought about that? Okay. You can also tell that it would be r cubed. You wouldn't necessarily have to draw them all out because how many, from the 15th to the 18th terms, how many times would you multiply by the common ratio? 3, because there's 3 terms in between it, right? And so you're starting at the lower term, 12, and you're going to multiply by that common ratio, r cubed, and then you'll get negative 96. Well, we can solve this equation. Divide by 12, we'll get r cubed equals negative 8. How do you solve r cubed equals? Cube root. We did this back in chapter 5 of first semester. You can do cube roots, you can do fifth roots, you can do sixth roots. Remember, you have a special button in your calculator. It's probably like underneath the square root button. It has that little X next to it. You have to type the index in first and then hit second exponent or whatever that may be. What is the cube root of negative 8? Negative 2. Okay. Now, there are some different ways that you could go about trying to figure out your a sub 1. Okay. Ideally, you're not actually going to divide all the way back on a quiz. Like if you were on the 15th term, I would hope you're not dividing by negative 2, dividing by negative 2, dividing by negative 2, because then it's easy to lose count, right? Like how many times did you divide by negative 2? So I'm hoping that you're thinking more like systematically, like a sequence. Although if that was just the third term, could I divide by 2 twice and get to my first term? Sure, like that would not be an issue. Okay. Here's another way that you can go about solving for something that's missing. So I kind of mentioned this right over here on the sideboard. Here's my rule, right? So this is for people who just kind of want to be able to like plug and get an answer, right? Okay, I can choose either one of these terms. I'm just going to choose this one, a sub 15 equals 12. So in this notation, I know 2 things. I know n is 15, and I know a sub n is 12. Like the x what I put into the rule was 15. The y, what I got out of the rule, the term of the sequence, was 12. So I can make those substitutions with my r. 12 equals a sub 1 times negative 2 to the 15 minus 1, which I'm going to put 14 there. Are you okay with that? And then how would you solve for your first term? If it's being multiplied by something. Divide it. So divide both sides. Someone could, if they wanted to, type into their calculator, but can you imagine this? Negative 2 to the 14th. That's a big number. Okay, so I'm okay even if you want to leave it as negative 2 to the 14th. It's not going to bother me one bit. Then I can plug that in. A sub n equals 12 over negative 2 to the 14th times my r, which was negative 2, to the n minus 1. Now, technically, there could be some simplifying because we have same basis, so we could subtract our exponents. But I'm also okay just because this one is so small. This is so big, and this number gets so small that I just wrote it as a fraction. If you want to do negative 2 to the 14th and write that really big number, you can. I don't think it's in scientific notation. 2 takes a while. Yeah, it's just 16,384. So if you wanted to do that and then like simplify the fraction, you could. Oops, sorry. So this right here is 12 over 16,384. Of course, I could reduce that, which my calculator will do nicely. Okay, so I could write it like this too. Either one is fine. All right, your homework is on your gold sheet. We still got a couple minutes left, so hang tight. We're done with sequences. Some of us have not been putting in any kind of effort into writing rules, and that quiz gonna be hard. So you gotta just stretch your brain a little, let your synapses grow.